Hello and welcome to PSYC3020, our next online video tutorial lecture. And what we're going to try and do this time is I'm going to teach you all about how to use SPSS to analyse psychometric measures. So, for example, this will be very useful for assignment 2, where you will literally be having to do what I'm going to show you today on your very own data. Because if you don't want to listen to this video, you always have the other option of just downloading the slides, which are designed to be fairly self-contained, and just reading them instead. So let's go. First, let's go over some of the aims of this online lecture so you know what the point of all of this is. So first of all, you need to know that in assignment 2 for this course, the aim will be to design a measure of a personality trait. So each tutorial group will get their own personality trait, and you'll be creating a measure for that. And part of the process of developing that measure involves creating the measure, collecting data on that measure, and then analysing that data using SPSS, which is a statistics package I'm going to show you. And the point of the data analysis is to try and determine the psychometric properties of your scale. So essentially, to what extent is your measure reliable and valid? So is it any good or not? What we're going to do is a dry run for this in this tutorial is to do this using a driving behaviour measure. So in fact, 2 driving behaviour measures. So I've got a data set here which involves the speed questionnaire that you saw in lecture 1. It also involves a traffic violations questionnaire. What I'm going to do is outline the overall process first of all, and then go into SPSS and show you literally how to do each of the steps. Importantly, notice I'm going to be using a slightly doctored data set to the one you're going to be having a go with a bit later in this tutorial. So the key thing is don't just copy the output that you see coming up on this screen, because it will be different from the output you come up with. There will be a whole bunch of online tutorial questions following this, and they'll be asking you to do various bits and pieces that I have outlined, but I'll flag each of those potential questions up as we go through the lecture so you know what to expect. So one potential way you could approach this is to have this video open in one window and also have SPSS open in another window so that you can try things out as we go along on the data set. Right, so here's the overall framework of how we create a measure of human behaviour, and mentioned this in lecture 1, but we'll go over this in more detail in lecture 5. So let's start with the obvious stuff. First of all, you want to decide what you're going to measure, why you want to measure it, and how you're going to measure it. Okay, well, I say obvious, but sometimes people forget one or more of those things. Second thing you need to do is create the actual materials needed. So in the case of assignment 2, that would be literally writing the questions and response options that are going to make up your questionnaire. The third thing we do is to take the questionnaire and try it out on a large sample of people, where we're effectively creating a study where the aim of those study is to assess the psychometric properties of the new measure, so reliability, validity, and issues related to standardization and also item quality. Fourth step, if it all works, then we can sometimes do some iterative improvements to your measure using the data that we've got from those studies. And finally, you've got the whole thing finished, you let it free. Right, so step 3 is the one we're focusing on today, and this is step 3 broken down into its constituent parts. So first of all, we have to think up some hypotheses which are going to test the validity of our test, so evaluate how well the test can measure what it's supposed to measure. Then we collect data from a sample of people who complete the measure, plus whatever other variables we need in order to test validity and reliability. We take all that data, we import it into SPSS, and now we're getting into the bits we're doing right here and now. So this is step 4, where we're going to check the data, Step 5, we're going to score the measure and any other measures that we require. Step 6, we're going to check the distribution of the measure. Is it normally distributed or not? Step 7, if there's a problem with the distribution, so for example it's badly skewed and we want it to make it more of a normal distribution, then this is the point where we might want to apply a nonlinear transform. And 8th step, we'll go ahead and calculate the reliability of the measure. So the one I'm going to show you today is known as Cronbach's alpha. And 9, then we run a whole bunch of analyses to test the validity of our test. Right, the next step, which is something we're now on to the bits we're not going to cover today, but we will cover later in the course. The next step is to run item statistics, and these tell us how good each individual item is, which gives us a handle on how we can potentially improve our test in the future. And step 11, which is something we'll do today, is just to output some descriptive statistics which we'll need for the participant section when we write up our report. So just saying how old people are, what gender they are, that sort of thing. And finally, you write up the report and submit it. So what I'm going to cover now is the basics of SPSS itself. So hopefully most of you are familiar with SPSS already if you've done 3010 or other courses, but in case you haven't, here's your start point. So in SPSS you've got a basic window structure which looks a little like this. Alright, so first of all there's a statistics data editor, and this is the thing that opens when you open SPSS for the first time, and within that data editor it gives you two views which you can get to by little tabs at the bottom of the screen that I'll show you. And the first view is called the data view, which is essentially a spreadsheet where every row is a different participant and every column is a different variable. And the other tab is known as variable view, which is just a list of your variables and various parameters to do with those variables. Right, the second window is the statistics viewer. So this is one that pops up when you actually do something, you run an analysis. It pops up as a separate window with the results of those analyses in that window. And the third window, so this is the one that we probably won't touch very much on in 3020, but you may touch upon in other courses. So this is where instead of just going through the menus to run commands, you can actually paste them as syntax, as computer code. However, we probably won't touch upon this, but I'll just mention it so you knew it was there. There's the SPSS icon. I click on that and up pops SPSS. Here's one I uploaded some data into earlier, and what we've opened up into is the data view. So you can see this tab here, and you can see this is the spreadsheet as described, and we click onto this tab here. This is becomes the variable view, where you can see for each variable it's got the name there, it goes across and it has all attributes such as our values, missing values, alignments, that sort of thing. Let's go back to data view. If I run, say, a very simple analysis, let's do descriptives of age, so it's finding out how old people are. Okay, I'll go, don't worry what I'm clicking in at the moment, all I'm trying to do here is to get this window here to pop up, and this is your output window where we can see now that age, for example, for this data set has a minimum of age 18, maximum of age 72, with a mean of 35. Right, here's what you need to do. So, use your UQ username and password to log on to the SPS computers. So, I'm guessing you've done this already or you wouldn't be here. So, let's hop over this. And importantly, the data file you're going to need for this tutorial. What you need to do is go to the PSYC3020 Blackboard website and then click on the week 3 tutorial, and on that you'll see one of the items is the week 3 tutorial dataset. So the first thing you need to do is just download that and stick it somewhere safe. So one option is to save it onto the H drive of the computer you're working on, so assuming you're in the SPS labs now. Anything you put here should stay there for you. However, if you want a safer option, then you can also save it to a USB key, because those H drives are wiped periodically, at least at the end of the semester. So find the icon for SPSS, which should be on all these SPS machines somewhere, and open it up. And then from within SPSS, go to File, click Open, and go and dig out the dataset you've just saved and open it up. Importantly, as we go through this process, and in fact more importantly when you come to your assignment 2, I suggest you just hit Control S fairly often, because it's the case that computers do crash from time to time, and this will allow you to save your work. Here's the dataset. Okay, the data set that we're going to look at is genuine data from a sample of UK drivers from one of my previous studies, and this data was created by people, these drivers, filling in a questionnaire I'm about to show you. I've shortened it just for the purposes of this tutorial. So you can download the questionnaire in PDF form from the Blackboard website, so that just to allow easy viewing. And what I've done is, for this PDF version, I've annotated it with all of the SPSS variable names we're using, and also the codes you'll need for the analysis. So for example, for the variable gender, I've coded males as 1 and females as 2, so you need to know that if you're going to do any analysis on gender, for example. Okay, so look for the boxes like that next to each item. That tells you exactly how the item has been coded in the data set. And here's the questionnaire. Okay, so let's look up here first. So this is the beginning of the questionnaire, and as you can see, it's a study on driving behaviour. It's actually the original version. This is from the olden days when we still did things on bits of paper. People have to fill in their age, their gender, years driving, and then roughly how many miles per year they drove. Okay, and then below that you'll see something you might recognise, which is that 3-item speed questionnaire I showed in lecture 1, but this time in its written format. So the idea is just supposed to circle one of these numbers on each of the scales. Okay, and following that, we look to the top of the next page, like so. We've got a second driving measure, which is a measure of driving violations. Okay, so this is the extent to which you're likely to commit traffic violations. Okay, so you can see the sort of typical items there, 8 items. How often do you drive especially close to the car in front as a signal to its driver to go faster or get out of the way? How often do you become impatient with a slow driver on the outer lane and overtake on the inside? Okay, and there's a 6-point Likert type scale from never to nearly all the time. Okay, and both of these scales can predict crash involvement. So here's the steps we're going to go through in this presentation. So first step we're going to take is to check the data entry is correct. So we're just going to do some very rough things we can do just to check the sort of values people have entered and check there's no out of range values. Second thing we'll do is score the measures. So we had 2 measures there which had multiple questions in each measure. We want to combine all of the scores for the individual items into a single score for each measure. Third step we need to do is look at the distribution. Is it normally distributed? Because if it is normally distributed, that's very handy for statistics. Fourth step, if it's not normally distributed, but we do want to do things like use parametric statistics, one thing we can try out is a non-linear transform. So for example, we take the square root of all the numbers, or we take the log 10 of all the numbers. Okay, and this sometimes can help make distributions more normally distributed. Once we've dealt with all of that, we can calculate the reliability, and the example I'm going to show you in this tutorial is Cronbach's alpha, which is probably the one you're going to be using in your assignment 2, unless you choose some absolutely bizarre format of question. And here's the sixth step where we actually run the analyses associated with testing validity. And when we're testing validity, we're running analyses like correlations, t-tests and things like that. So you saw some examples of that in the correlation online lecture we had last time. Here are those 6 steps, and let's look at step number 1 first. We're checking the data entry is correct and looking for out of range data points. We can do this by going analyze data, descriptive statistics and frequencies. And what I'm doing here is I've just listed out all of the steps you need to go through just for easy access. So what this means is you can print out the PDF of these slides, and that is literally your instruction manual for running all of these things. But rather than read all of this out for you, I'm now going to hop into SPSS and instead show you all of the things on this screen. Right, analyze, descriptive statistics, frequencies, click. Right, there's my dialog box opens here from my list of variables here. I can just pick the things I want to look at. So let's pick those 3 speed items. I go click and I click OK. My output window automatically opens. Here it is, and as you can see, let's expand that. I now have a frequency table for each one of these questions. So you can see, for example, for the question, how often do you exceed 70 miles an hour on the motorway? These are how many people responded to each of the response options in that sample. So we look at these frequency tables to try and get a feel for how many people responded to each item, the distribution essentially, and also to see whether there's any obvious silly values in there, because that will be immediately apparent in those tables. Obviously these data I've already cleaned up already, so there aren't any silly values. But one thing we can look for with this sort of data is whether any of the questions don't have a good enough range. Remember from last week where one of the key things with these sorts of questions is we need a good spread of scores to avoid restriction of range problems. Are any of these questionnaire items, for example, failing to tell people apart because the range of scores we're getting is limited? Is not covering the full range of the scale. And right now we're on to the very first quiz question you'll encounter when we get out of this lecture. So if you had to delete or reword 2 items from the violation scale on the basis of score ranges, which items would they be? And I'll just jump back to SPSS so we can to show you what I mean. But just bear in mind, in lecture 5 I'm going to show you a better way of doing this sort of item analysis, which is the one you'll be using in assignment 2. Right, analyze, descriptive statistics, frequencies. I'm just going to reset that, and this time I'm going to choose the 8 violation questions and click into there and click OK. Here comes our frequency tables. Looking at each of these questions in turn, which of them are having the most problem with restriction of range? Okay, bear in mind that your data is slightly different to this one. So for example, for this one I can pick out item number 4. It looks like about 87% of people are responding at the lowest point on the scale, with very few people above that, so this is clearly an item with a bit of a problem. The second step is to score the measure. First thing to consider is whether we need to recode any variables that might be worded the opposite way around to the other variables. So typically in rating scale style questionnaires, the way you get an overall score for the questionnaire is to add up the scores for each of the individual questions together to get a total score. But of course you've got to reverse the coding of any questions that are worded back to front. So this is how to do the reverse scaling. You don't need to do this in this particular tutorial because there aren't any reverse scales in either of the measures I've included, but you will probably need to do it for your assignment 2, so I'm going to show you how to do one anyway. Right, first obviously identify any items that are reversed, then go through these steps here. Okay, I'm just going to click through these now quickly, but remember the instructions are here for you when you come to do it for real, because instead of talking through these, I'm just going to show you. Oh, transform, go down here, recode into different variables, click there, opens this dialog box. Let's select a variable which will pretend needs reverse coding. That is, it could be that all of the other questions are asking about how often you do something dangerous. Maybe this is asking about how often you do something safe, so we need to swap the scoring around to make it consistent with the others. So I click this arrow, it pops up here. Okay, we need to write a name for the new reversed variable, so let's call that violate1 reversed. Let's click change. Okay, so violate1 is going to become violate1 reversed. Now let's click on old and new values. Okay, remember it's a 6-point scale from 0 to 5, so that means all 0 values, see old values here, will become a new value of 5, and then I click add to put that here. Old value of 1 will become a value of 4, like so. 2 will become 3, 3 will become 2, 4 will become 1, and 5 will become 0. Okay, so looking down here, that's the full range of the scale, and the whole scale has been completely reversed. That looks good to me. Let's click continue, and that's all we need to do. Let's click OK. Right, let's go back to our data view, and we can see here that now we've got a new variable has appeared at the far right, so you might have to scroll across to see this, and you'll find that this is the first violation question, but with all the values now back to front. Now what you want to do is calculate the total questionnaire score for each person, and here's how we do this. So in this particular questionnaire we've got the speed questionnaire, we've got the violations questionnaire. For both of those, all you need to do is add up each of the items that make up each one of those. Okay, and we do that via the transform menu and choosing compute. So here's the steps you need to go through as your reference, but I'm just going to skip over these and show you. So transform, compute variable, and here we are with the dialog box. First thing I'm going to do is type in this target variable the name of the overall score. So for the speed quest, let's call that speed quest questionnaire, or I can call it whatever I liked. Okay, and then I go to my numeric expression box, and that's where I want to pick up the 3 items that are part of that speed questionnaire. So exceed 70, drive fast, speed urban, click on each one, enter it there, click on plus, drive fast, enter it there, click on plus, speed urban, enter it there. Okay, there we got everything we need. Now I click OK, and you can see that the complete speed questionnaire total has popped up on the far right in your data view. Right, now we're on to step 3, where we want to check the distribution. Right, 2 things we're going to do to check the distribution. So the first thing is to look at the skewedness statistic, which is under the descriptives option. And second thing we're going to do is produce a histogram, which is under the graphs option. So let's show you how to do that right now. First of all, I go to Analyze, Descriptive Statistics, and then to Descriptives. Let's click on that. Opens this dialog box here. Okay, I'm interested in the speed questionnaire, so I'm going to click that into the variables box. Now I'm going to click on Options, and I'm going to tick the box that says skewedness. Now I'm going to click continue and OK, and here's the output that's popped up. So for the speed questionnaire, here's all of the descriptive statistics it's come up with, but importantly, here's the skewedness. It's a number of minus 0.27 with a standard error of 0.14. Second thing we're going to do is look at histogram. Let's go to Graphs, Legacy Dialogues, Histogram. Click on that. Let's grab our speed questionnaire again, paste that into the variable box, and click OK. There is the histogram for our speed questionnaire. So now we've got our histogram and we've got our skewedness statistic. How should we interpret them? Well, one of the quiz questions you're going to get confronted with is which out of the speed questionnaire and the violations questionnaire is more skewed. So we can look at the histogram for both variables to see which looks more skewed, but we can also look at the skewedness statistic for each variable and see which one of them is farthest from zero, and it could be farthest from zero in either the positive or negative direction. Another question we might be interested in is how big does that skewedness statistic have to be before we need to do something about it, before we need to do something like transform it? Well, there's all sorts of different ways you can work this out, but the simple one we're going to use in this course will be to say if the skewedness statistic is either greater than +1 or less than -1, then we're going to call that variable skewed, and therefore want to go ahead and do some transformations on it, or failing that, do some non-parametric statistics. Okay, so notice that if you look in SPSS help, they do give you an alternative criteria for interpreting that skewedness statistic, although some people might argue this is only appropriate if you've got smaller samples. So this is the output from descriptive statistics, where the skewedness variable is over here. So this is for miles per year. You can see that the skewedness statistic is 1.93, so that's much greater than 1. Therefore this variable has a substantial positive skew, and we'd want to do something about that. Which brings us on to the fourth step. So what do we do if one or more of our variables is not normal, is not symmetrical? Two options. First thing you can try is a non-linear transformation, and the ones we're going to try in this course are a square root or a logarithm. All sorts of other ones you could try, and both of these have the effect of stretching some parts of the scale more than other parts of the scale, which may potentially make your data look less skewed. The other option you've got is if that doesn't work, then instead of using parametric statistical tests, you instead use non-parametric statistical tests. So for example, you would use a Wilcoxon test instead of a paired t-test, a Mann-Whitney U-test instead of an independent samples t-test, Spearman's row correlation instead of Pearson's correlation. And I'll explain how to do these a little bit later. But for now, let's go over how to do a non-linear transform. Here's the instructions for your reference. But let's just get on and do it. So, transform, compute variable. This time, what we're going to do is put the speed questionnaire in this side here, and I'm going to do a square root transformation. So, square root is SQRT, open brackets, and close brackets around my variable. In target variable, I'm going to type new variable name. Let's call that square root speed quest or something like that. And by the way, you can find all of the function you don't have to type it in, you can have it pasted in. So if I click on function group arithmetic and go down there, there's your square root, and the other option that you might want to use is log 10. Okay, so I've got all of that. I then click OK. Now let's look at the end of our data set, far right hand side of data view, and you can see the square rooted values of the speed questionnaire have popped up there. Now what I'll do is analyze descriptives, and speed questionnaire is there already. Now I'm going to put the square rooted speed question in there too. Check my options, it's got skewedness, yeah. Click OK. And you can see in this particular case, the speed questionnaire, it wasn't very skewed to start with. We've done the square root, and now it's actually massively skewed, so that's had the opposite effect to what we wanted. What we really wanted is for that number to become closer to 0. Right, here's another quiz question for you. See if you can reduce the skew of the speed measure and the violations measure using both a square root and a logarithmic transformation. And does this help reduce skew for either variable? So essentially you have to just go back through those steps I've just shown you, do it for both measures and do it twice for each measure, once using a square root transformation and once using that log 10 LG10 transformation, and then look at the descriptives and see which transformation, if either, helps reduce the skew. A little note here is that when you run that logarithmic transformation, it may throw up a little error message for any participant who scores 0, because you can't take a log of 0. So if we really wanted to, we get around this by just adding 1 to everybody's score, so it has no effect on any of our further stats, but it gets around the problem of there being zeros there. However, for the purposes of this demonstration, just ignore it because it's only a couple of people in this particular sample. Right, so 5th step, we calculate the reliability of our multi-item scales. And here's how we're going to do it. One estimate of reliability is internal consistency, and for the two measures here we're going to be using a statistic called Cronbach's alpha, which is a statistic you'll probably end up using for your assignment 2 questionnaires. And effectively this is the average correlation between all of the different items in your questionnaire. It's the extent to which all of the items in your questionnaire are measuring the same underlying thing, and we'll talk about that in lecture 3. It tells you whether people respond similarly to each of the questions. If this Cronbach's alpha is high, okay, where the highest it can be is a 1 because it's effectively a correlation. If that's high, if it's 0.8, 0.9, what that means is that people tend to give the same or similar responses to each questionnaire item. So for example, if that speed questionnaire has good internal consistency, it means that someone who says exceeds 70 miles an hour frequently also tends to report driving fast and speeding in urban areas frequently. So these are the steps we go through to calculate Cronbach's alpha, and again, here are the steps just for your reference. One for assignment 2, it could be that, for example, in your questionnaire you might have more than one subscale, in which case you might want to work out alpha separately for each subscale if you think that the two subscales might be independent of one another. So here's another quiz question. You have to go and work out what the internal consistency of the speed questionnaire and the violations questionnaire, what they are. So here we go. Let's go to Analyze, go to Scale, go to Reliability Analysis, and then we see we've already got our model alpha for Cronbach's alpha down there. Now I'm going to, for the speed questionnaire, pick out the 3 items. I'm clicking all of them by holding down the control key while I click, and then using this arrow to paste them across here. Then I'm clicking OK. Here's the output, and the Cronbach's alpha is 0.77. So note that this number will be different from when you do it, because I've modified this data set for the purposes of this demonstration. Now the 6th step, and the last step, where we work out what the validity of our measures are. The way we measure validity is to come up with some predictions for how we would expect our measure to behave, to relate to other variables that we have, if it's measuring what we think it's measuring. So, to give you an example, the speed questionnaire, the prediction was that it would predict participants' actual driving speed, and it would predict their crash risk, and so we looked at correlations between those two variables. The correlations were significant and of a reasonable magnitude. Therefore, the people who designed the speed questionnaire concluded that that speed questionnaire had some degree of validity. For assignment 2, you have to come up with predictions of how your scale will associate with other variables if it's measuring what you think it's measuring. So, for example, I might predict that older people drive more slowly than younger people. So for example, I might have observational evidence that shows that that is the case. That means that if our speed questionnaire is a genuine measure of speeding, what we might expect is for there to be a correlation between age and the speed questionnaire score, and it would be a negative correlation because as age increases, the speed score would go down, and that would be consistent with what we find in observational data. So we know that speeding and committing traffic violations map on to both age and gender differences in real life. So that is, younger drivers and male drivers tend to drive faster and they tend to commit more violations. So this means one way of testing the validity of these two measures of violations and the measure of speeding would be to see whether they can replicate that pattern of findings. And if they do, then that's evidence which is consistent with the idea that both are measuring what we say they are. So to measure validity, we need to look to a whole range of our sort of typical statistics. So in this course, you'll either be looking at correlations or t-tests, but in principle you can use ANOVAs or regressions, whatever it takes to test a hypothesis, in the same way you would test a hypothesis for any empirical study. So to start off with, here's how to do a correlation in SPSS. I go to Analyze, I go to Correlate Bivariate, because there's two variables, and for example, let's look at the correlation between age and drive fast. Okay, so first of all, I click on age, click the arrow, click on drive fast, put it into the variables box by clicking the arrow. Then I choose a correlation coefficient, so that's the Pearson, that's the one we would use if we were confident both those variables were normally distributed. But let's tick Spearman as well, that's the non-parametric one if, for example, one of those variables was not normally distributed and our transformation had failed to reduce that skew sufficiently. Now we click OK. Here's the output, here's the parametric correlation, so between age and drive fast it's minus 0.22. That's highly significant because it's such a large sample, but a relatively weak effect. Okay, so that is, as people get older they tend to indicate they drive less fast, and that's consistent with what we find with observational data. Let's have a look at the Spearman's row. So you can see in this particular case, Spearman's row is nearly identical to the parametric version of it, indicating that at least for this one, any skew in the data isn't having very much of an effect. So here's the correlation output again, and what I'm going to show you now is how you convert this output into what you would actually write in your report. So we would typically say something, for this particular example, something like the correlation between the exceed 70 miles an hour question and age was significant, and then you put a comma, and then you put lowercase r, and then in brackets you put the degrees of freedom, which is the n, the number of people, which in this case is 294, minus 2. So it's n minus 2 is your degrees of freedom, which is what you put there. Then you put an equal sign, and then you put the actual correlation, minus 0.182, and then you put a comma, and then you put a lowercase p for the significance value, and then put equals, and then put in the significance level, which is here. And then you typically follow it up with some statement interpreting what the correlation actually means, and importantly indicating what the direction means. In this case it indicates that younger drivers reported exceeding the speed limit more often. One thing to note is in SPSS, if we've got something that's very highly significant, it will say p equals 0.000, but whatever you do, don't write p equals 0.000 in your report. Instead write p is less than, so this little arrow here, p is less than 0.001. The other analysis I'll show you is if we want to compare two different groups, such as males and females. So, for example, we know that in real life males tend to drive a little bit faster than females on average, and therefore if our speed questionnaire is reflecting real life, we would expect males to have higher scores on the speed questionnaire than females. And to test this hypothesis, I need to do a t-test, specifically an independent samples t-test. And now I'll show you how to do this in SPSS. So for a t-test, I go to Analyze, Compare Means, Independent Samples t-test. Click on that. Okay, now I'm going to, let's look at gender. So let's click on sex and enter that where it says grouping variable, which is essentially independent variable. But I want to be able to tell it now what the two groups are coded as. So I'll click on Define Groups. That opens up this little box here, and if I look at that PDF of the questionnaire that this data came from, I know that males were coded as 1 and females were coded as 2. So males are going to be group 1, females are going to be group 2. When I've done that, I click Continue. You see the numbers appear here. Now I'm going to do, let's look at our gender differences for Violate 1, for example. Now I'll click in that in there and hit OK. So here's the results. Up here we have the descriptive statistics, that's how many males and females are in each group, and that's the means for question Violate 1 for those two groups. And here's our significance test. So for the significance test, first of all we need to look at this Levene's test for equality of variances, and that's this value here. And if that is less than 0.01, it means that we can't assume the variances of those two groups, the males and the females, are equal to one another. So that is, it would mean, if that was significant, it would mean that, for example, the males' scores were more spread out than the female scores, and it would mean that we would then have to look down this line, equal variance is not assumed, and report this t-value here, and these degrees of freedom here, and this p-value here. However, in this case, because that's not significant, it's greater than 0.01, it means that we can assume that the variances of males and females are approximately equal to one another. So we can follow this equal variances assumed line here, and instead we're going to report the t-value here, 2.2, and the degrees of freedom 291, and this significance level here. So here are some notes for your convenience, showing you all the stuff I just demonstrated in terms of using that Levene's test. Also here it shows you how you should report a t-statistic in your results section. So it's lowercase t, open brackets, inside the brackets go the degrees of freedom, in this case 391. That equals the actual t-value, which in this case is 3.996, and then you put a little comma, then a lowercase p, and in this case p is given as 0.000, so you would write that in your report as p is less than 0.001. And here's the quiz question you're going to be confronted with shortly that maps onto all the stuff I've just shown you. So we know that speeding and committing driving violations both map onto age and gender differences in real life. Do the questionnaires follow these patterns? So essentially you'll need to run the sort of analyses I've just shown you. You'll need to present the results in the correct format, and you'll need to indicate what the results actually mean, and then make a judgment about whether that is consistent with the scales being valid or not. In the past, with assignment 2, some people have been confused about when we want to look at relationships with variables like age and gender. So that is, they've put in an analysis of age and gender with their questionnaire measure without necessarily having a validity hypothesis associated with it. So the clear answer here is that age and gender just happen to be two variables we could potentially, but not necessarily, use to investigate the validity of our questionnaire. You would only put in a statistic looking at age and gender if it was important for one of the hypotheses relating to the validity of your questionnaire. If you didn't have a hypothesis relating to how your questionnaire changes with age and gender, then you wouldn't analyse these directly. You would just put them in as descriptives where you describe what your sample is like. So a few extra notes for you. If your questionnaire is skewed and none of the non-linear transformations I showed you succeed in reducing the skew, then you'll need to do non-parametric tests instead of the parametric tests, such as the t-test. Okay, you don't actually need to do this in the tutorial, but I just need to show you this in case you need to do it for your assignment 2. You can find most of these non-parametric tests by going to Analyze Non-Parametric Tests and then choosing Legacy Dialogues and picking the appropriate option. So here's the parametric test with a non-parametric equivalent. So if it was a paired t-test you really wanted to do, its non-parametric equivalent would be a Wilcoxon test or a sign test. But in SPSS you would want to choose the option that says 2 related samples. For an independent samples t-test, a Mann-Whitney U is one of the things you could run. In that case you choose the 2 independent samples option in SPSS. For one-way unrelated ANOVA, choose Kruskal-Wallis, which is the option K independent samples in SPSS. And for a one-way repeated measures ANOVA, you want to do a Friedman's test, which is where you choose K related samples in SPSS. And finally, the easy one, the parametric correlation is Pearson's R, and its non-parametric equivalent is Spearman's Rho, and I already showed you how you can get that. You just do a normal correlation and then tick the box that says Spearman. So final thing we'll do is look at how we're going to calculate the data we need for the participant section of your report. So this is where we're just describing the sample, we're not actually running any inferential statistics. So what last thing we're going to do is actually work out the variables that will go into this section. So here's the quiz question you're going to be confronted with. What are the mean age, miles driven and years since passing the driving test for the sample in this data set, where you want to put in the mean and the standard deviations. And another thing you want to know is what proportion of the sample are female. You've already got all of the statistics you need to be able to work this out, so you would use the descriptive statistics to work out the mean and the standard deviation, and for the proportion of the sample of female you would use that frequency command that I showed you earlier. So that's about it. You should now have pretty much everything you need to complete the online quiz, as well as all the information you need to attempt at least most of the analyses you're going to be doing when you evaluate your own measure in assignment 2. So essentially all of these things I've been showing you today, they amount to building up a body of evidence relating to the psychometric properties of a test. So effectively its reliability and its validity. And when you do get around to analysing the data for assignment 2, the idea is that you can use the PDF of these slides as your SPSS reference guide. And that's it. Good luck with it.